I think that's the trick that one of
Well, yeah, I know, but they change, man. Watch this one. I mean, I don't like to get
Okay.
I don't want to get too mean, but
It's okay.
I mean, again, when we start making these generalized rules in our brains, there might be exceptions, you know. So maybe in the last problem you just said, okay, so when there's a number on top, it's one of these, you know. And then if there's a variable on top, it's not one of these. Well, there's an exception to that. So. And the key would be maybe to try things. You know, a lot of this stuff's trial and error. And maybe you try u equals something and you chase it and it goes down a bad road and you abandon it and you try u equals something else. Okay. But this time, again, I'm paying attention to the power on x, you know. And I am thinking about this formula, and if I am thinking about this formula, and if I'm thinking that this could be a u squared, then what is u?
X squared.
So if u squared is x to the fourth, then u is x squared. Okay, then what's du? I mean, I don't even wait. It's the first thing I do is find du. Du is the derivative. 2x dx. And now I'm not so confused about why there's an x on top. That x on top is going to get absorbed into this du. And I think I'm headed toward a classic arc sine now here. Let me try to work on it. What about the 7?
Pull it out.
Pull it out front. What about this x dx? What is x dx?
1/2 du.
He says it's 1/2 du. All right, I'll put the du up there and I'll put the 1/2 out here. All right. What about my denominator? What's my denominator? The square root of 1 minus u squared?
Yes. Yeah.
All right, so now this u substitution is about playing. It ends up fitting a form. You know, it could be e to the u. It could be 1 over u. It could be u to the n. You know, those are all things we dealt with. It could be cosine u, tangent u. Anyway, this one is this form. And this form is this form. And that's what it is, isn't it?
Yep.
Okay, so we're done. It's the arc sine. So it's the arc sine. It does have a 7/2 out front.
Right.
But it's the arc sine of u over a. And the a is a 1. And so it's just the arc sine of u. You could, you know, u over 1. So there we are. We're done. I say we're done. You should always
U is x squared.
X
Yeah.
plug back in what u is. Yeah, u is
Okay.
u is x squared. So, like I said, I just found an exception to some of your thoughts. So every problem is sort of attacked individually.
Right. So if that didn't work out, then I would go try 1 minus x to the 4th. Yeah, I got it. Makes sense now.
You guys might have a lot of cool things to ask me, but while we're on this topic, maybe I should stay here a minute and show you the hard part. You want to see the hard part?
Yes. If it's going to be on the test.
Well, you know, I'm going to show it to you whether it's on the test or not. So, I don't know if it's on the test, but I mean, this is a big chapter with a lot of stuff. But everything I've done can't make the test, or you'll have a 100-question test. So I don't know what makes the test and what doesn't. But this is the last difficult topic I need to show you before this course is technically over, maybe. And here we are. We're in 5.8, but the last little difficult part is this. Watch this. This is classic, 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 classic. So see this guy?
Okay, yes.
So can tell you what to do and how to do it. What I'm trying to pretend is if I'm you and I'm staring at this, what would I be thinking? And anyway, I just want you to realize that as it sits, it's not this. You know, with this a squared has to be a number. It can't have a variable in it. So there's no way that this is a squared. You could think of that as u squared, but anyway, this is not this. At the moment, it's not this. You with me?
Yeah.
It's not an a squared. It's not an a squared. A squared's got to be a number. If I tried to do u substitution somehow, the du, I'm thinking ahead, the du ain't, it's going to get messy. I don't think it's going to work.
Yeah.
Okay, now what I like is y'all to give me ideas, but then usually what I do is I chase down your ideas and show you where they're wrong.
Yeah.
So let me just chase her idea. No, I don't know. What did she say? You said factor out an x? I mean, if you factor out an x, it looks like that. I mean, okay, and then, so it ain't out of the square root. And okay.
It's not gonna help.
So that didn't go too far. Okay, good. So that's the thing though. You stare at it and you might chase down all these ideas. They're all going to be wrong until I tell you the right way to do it, which I haven't taught you yet. So let me show you. The right way to do it is to complete the square.
Oh, geez.
I hate completing the square.
Yeah. I already did.
All right, listen, dude, it's the last thing. I got to get it out. Whether you hate it or not, we got to get it out. All right, listen. So here's what I do. I go over to my scrap paper. Watch this. And I take the 6x minus x squared. I just go over to my scrap paper and I want to complete the square. All right, in order to complete the square, I want to write it in order. So I'm changing the order to negative x squared plus 6x. Also, in order to complete the square, you never complete the square when there's a coefficient in front. When there's a coefficient in front there, you can't complete the square. So you need to sort of factor it out. So I'm factoring out a negative sign, which changes this sign.
Correct.
Right, so far, I haven't done much. Now I'm ready to complete the square. I want to add the perfect number that makes this a perfect square trinomial. And the perfect number is always half of that squared. So I'm going to add a 9. Okay, now watch. I'm going to add a 9. Now, wait a minute. You can't just add a 9 unless you go subtract a 9. I mean, that's how you balance it. I mean, I just added a 9. That's illegal unless I subtract a 9 to make it back. I didn't do anything, right? Listen. Okay, hold on. Hold on, though. This one's tricky because I added a 9, but wait a minute. I added a 9, which makes me think I should subtract a 9. Wait, hold on. This added 9 ain't really an added 9. Look at it. Look at it. Look at it. Look at it.
It's a negative.
It's a negative 9.
So you need to add a positive.
So I really need to add a 9. Wait a minute. I thought I added a 9, but it was really a negative 9. So to do the opposite of that, I need to add a 9.
Yeah.
It's logical. Now watch. This is a perfect completed square. What is it? That's the whole point. It's an x minus 3 squared. I mean, if you know algebra, that's a perfect completed square. That was the point. It's a perfect square trinomial that factors into a perfect square. That was the point. This is a plus 9. Now I want to write them. Now I want to write these in the opposite order. Watch this. 9 minus x minus 3 squared. So that's all the completing the square work. Now I go back here, and what was inside this radical just changed his look. What was inside this radical got changed into that. That's cool, huh? I mean, it's cool. It's sophisticated end of Cal 1 stuff. Are you guys taking Cal 2? There's sophisticated, badass calculus in Cal 2. I mean, you got to be good. You got to be good. You can't be cruising. You kind of gotta, you gotta be into it, man. You gotta be into this stuff. Sorry, can't be part-time. But
So it's an arc sine.
do you see that? That was cool, huh? Completing the square. It's just manipulating the form is kind of what it is. But now it looks like this. Do you see the benefit of what just happened? Do you understand what just happened? Maybe you don't see it too cool. Do you see an A? Do you see an A? Do you see an A?
3.
I think A is a 3. If A squared is 9. Do you see what might be a U
X
squared?
minus 3.
So if that's U squared, then my U is X minus 3. You know, if your U is X minus 3, that's not a very exciting DU. What's DU? dx. When it's not a very exciting du, I don't feel like even going through the motions. It's not going to spit out a 1/5 or a 1/2. I'm very ready to finish this problem. I'm ready to just shout out the answer. It's the arc sine of u over a. What's the u? X minus 3 over a. 3 plus c. I mean, once it's in this form, it's in that form, and can you read forms and write answers? But prior to that, it was a job to get it into this form. And the job was completing the square to get it into this form. Yes?
And you said, yay or nay, that that's going to be on the test.
I don't know. Yeah, is what I said.
So you can, never mind. I was going to ask you, because this kind of sounds stupid, but you designed the test, right?
Right.
You designed it, okay. Sounds like from your response, you're like, you don't know if it's going to make it.
But I don't know. I mean, I don't know because I haven't written it yet. But, you know, if this is too much for you, forget it. Don't study it. Don't worry about it. I mean, it's one question on you. If it is on the test, it's only one question. I mean, I wouldn't spend. If you're struggling with this, I imagine you might be struggling with a lot of Chapter 5, and so I would focus more on the rest of Chapter 5 and your regular old U substitution. And I mean, based on your quizzes that I've graded, you're struggling with other parts of Chapter 5. So, yeah, don't focus on this. But it's part of the course. It's the last little part of the course. It's 5/8 is these ideas, and then the last little tricky part of 5/8 is these ones where it doesn't really look like it fits the form, but if you complete the square, it does. That's this last little added thing here. So now the course is over. Yes, sir.
For this specific integral, would it on the test specifically say that you have to use trig identities? Because I know there's more than one way to solve this integral and not using it.
Really? Why do you say that?
I don't know. I just imagined making it a 1/2 power on the bottom, and then moving it up, and then doing the integral. Like
yeah, that ain't right. You got that's wrong. You know, that only works with. Let me see. What can I tell you? With this guy, it works. It's an x to the 1/2. You move it up. It's x to the negative 1/2. You knock out a power rule. You're totally right. You knock out a power rule. That's what he is. And you know what? It works with this guy too. You let u equal this, and then it's a u. Then it's a square root of u, and you move it up, and it's a u to the 1/2. And you know what? It also works on this. And by the way, and the du. What if this is u? If u, what's the du? 1 dx. So it's a very boring u substitution. In fact, you might not even do it. If you didn't even, you might not think about it, and it wouldn't hurt you because there's no.
Right.
But for a lot of things, like this one, you really have to kind of call that a u. Sorry. You really have to call that a u. What's the du? 5 dx. The result is this is a 1 over the square root of u. But the other result is when you replace that dx, what are you replacing dx with? 1/5 du. So the result is it spit out a 1/5. See, this one didn't spit out anything. This one didn't spit out anything. The u substitution process spits out a 1/5. Now you can go do what you said you wanted to do. Move it up, do a power rule. But there's a 1/5 out here from the U substitution. Okay, this one, in order to do what you said, he wants to pretend it's a power rule, move it up. You got to call that U. And it ain't going to be pretty because the du is nasty. I mean, this would be perfect if somebody had, look, if this was sitting on top.
Okay.
Now you're doing good. Yeah. Without that on top, it's not a good U substitution problem. It sure isn't. And so there isn't another way to do it. Yeah. See, y'all did that on, yeah. What else? Anything else?
Yes.
Yes.
A question from the second to this number 11, the calculation dp over dt. Can you
Okay.
do another example like that? 'Cause I think I need one.
Maybe. I like that question. Yeah. All right. So, you ready for this? He's asking about 11. Maybe I could do a different version, or maybe I could just help you with this version on your take-home quiz. What it says is dp dt is k square roots of t cubed. Is that what it says? By the way, yeah. Okay. Now, then if you got to read the words, and it says a couple other things. It says the initial size of the population was 700. You know, when you read that, the initial size of the population was 700, what could you write down? When t equals 0. Thank you very much. Yep, when you read that, that's what you should write. The initial size of the population was 700. Thank you. You should write that down. That's a piece of information that you'll use. What you'll do is you'll plug this stuff in and that'll help you find K or C or something like that. Let's see what else they said. The next sentence. After 2 months, the population was 2,200. And I'll write that. After 2 months, the population was 2,200. All right, those are good pieces of information I think I'll use. Now, but these pieces of information are about the population P. The equation they gave me is about the rate of growth of P. It's the derivative of P. Boy, I wish I had P. How do I get from the derivative of P to P?
Integrate.
I integrate. So I need to integrate to get to P. You know, I don't know if you like all these little technicalities, but just for technicality purposes, you kind of put the dt over here. Watch this. By the way, I'm going to write this as t to the 3/2. But you see what I just did? I put the dt over there. I don't know. And then you integrate both sides. It's sort of, I'm treating it like an algebra problem where but when you integrate this side, what do you get? When you integrate a 1 with respect to p, you get
1p.
You get p. And now you're integrating this with respect to t. You treat the k like a constant. And so the k sits here, and now how do you integrate t to the 3/2? You add 1 to it. So t to the 5/2 times 2/5 plus c. Look what you have here now. I think I might stop right here if you don't mind. Look, you have a population equation. You got it by integrating. That sure was easy. And you got this information here. And like I said, I think what you'll do is you'll start plugging this information into this equation. And I think this information will help you find those 2 unknown constants. Like maybe, I don't know, but somehow they will help you. I'm not saying those are the constants, but I'm saying this information will help you find the K and the C. Then what? Is there any other question? Oh, Then, see, you need to do that. You need to use this information to find K and C, because then you'll have a nice specific population equation, and then they do ask you a question. When T is 6, what's the population? But before I can answer that, I need to plug these in and get K and C. Should I do that for you, or you can handle that? You can probably handle that, I think, right? Yeah. Find your K and your C, plug this all in, you get a population equation, and then you can do that last little thing to answer the question, right? I mean, you can do it later, or whatever. Yes, ma'am.
Question 13 is, it doesn't specify if we're still on the moon or from Earth.
Oh, okay. Yeah, so 12 was on the moon,
Yeah.
and 13 doesn't say, so pick your favorite planet. Oh, Earth? Is that your favorite planet? I don't blame you. It's got good oxygen, you know, it's pretty cool place. Saturn's a little cold. Yeah, anyway, so I'm sorry, I'm not making fun of you. Yeah, so it's on Earth. So 13's on Earth.
Just
Yeah.
making sure.
Okay. Yes, ma'am.
Could you do 13?
Well, so that's a classic question. I'll tell you what, it was just like the one on you had a quiz yesterday that had that kind of question.
Yeah.
Maybe I'll help you with your quiz question instead. On yesterday's quiz, it said the same thing, except, okay, so you're on Earth. If you're on Earth, the acceleration is negative 32 for a falling object. See, now I'm helping you with your quiz the other day. Okay, you ready? But it's very similar to the 13. So now, how do you get a velocity equation? You integrate. And you integrate negative 32 with respect to t, and you get negative 32t plus c. But the plus c is the v naught. So I would just write that if I was you. But that's see, I'm doing this backwards now. And then if I integrate again, I'll get a position equation. We call position S. Now, help me integrate. It's not that hard. It's well, it's t squared divided by 2, so it'll be negative 16t squared. And then this is a number, like a 6 or something, or a 10, or whatever it is. It's a number, v naught. And then when you integrate with respect to t, it's v naught t. And then there's a plus c out here, but the plus c is the s naught.
Yeah.
The initial height.
Yeah.
In the height equation, it's s naught. In the velocity equation, it's v naught.
Okay.
Now on your hang on. So on your quiz the other day, it said you threw this thing up from ground level. We didn't know the velocity, the initial velocity. That's what we're asking for, but we said it started at ground level. So
0.
So S naught is 0. S naught is 0.
Right.
So this is 0. By the way, on your take-home quiz, it doesn't say that, does it?
No.
It's a 6, I think, right?
Yeah, it's 6.
Anyway,
Yes.
but anyway, let's not get mixed up. So on yesterday's quiz, it was a 0. And it also said it wanted to reach maximum height at 1,000 feet. Now here's the key, you guys. When it comes up here and it reaches this 1,000 feet, there's two things. I mean, it's obvious that the distance should be 1,000. The height should be 1,000.
Right.
But there's something else. If you're hitting max height,
Oh, the velocity.
the velocity stops. The velocity is 0 at that moment. So there's two ideas in this problem. This is 1,000 and this is 0. Those are the two ideas. Do I need to explain that better? Because you're reaching max height, at that moment you're there, it stops. There's no velocity just at that moment. So at the moment we get here, the velocity is a 0. Okay? And this is 1,000. And here's what you have. You're staring at two equations with two variables. You can solve and substitute and find the answers to the two variables. The t and the v naught. The only one I want is v naught, to tell you the truth.
Mm-hmm.
But you can do this. This was on your quiz the other day.
Yeah.
I'm about to give it back to you, but this was on the quiz. You were trying to ask me something. Well, while you were...
On the take home where it's asking, like in the bonus question, it says write the acceleration, velocity, and position formulas. If we can just figure those out in our head, like we just did with the gravity one.
Right.
I mean, do you want us to actually like write the integrate and write it out and plus c and then put it all in there, or can we just write the formulas?
No, you can just write these formulas.
Thank you.
Now, I thought you were asking me something about this problem, though. But anyway, you just, is that what you, okay.
Yeah, because
Okay,
I was
right.
just wanting to know.
Well, as I was writing those, you were thinking,
Yeah.
right, he's not showing much work. He's just integrating in his head.
Yeah.
And he knows that the plus c is the v naught. And yeah, right, I proved that to you once, and that now we can
We've gone
take
over
it,
those, and
take it
everybody
and
knows
use it.
by
Right,
now.
right. Good.
So we're done?
What's-
With that question?
Well, let's see. What are we doing? No, right. I was just saying we got the ideas are done. The idea that you needed was these ideas. And now, I was suggesting, I said that, hey, it's an algebra problem. You got two variables called t and v naught, and you got to solve two equations, two variables. So you solve and substitute, and I kind of thought, you can go do that. But you're staring at me funny, maybe I should help you do that. So, I don't know, what would you do?
Substitution.
Right, how? Like what?
You subtract the v naught over to the 0,
Okay.
and then change the signs, and then plug that in the bottom equation.
Oh, okay. Or add this over here.
Oh yeah, add that.
Yeah, that's cool.
Yeah.
So hang on. So v naught is 32t, is what he just said. So he's saying he wants to stick that in the other equation. All right, that's cool. Here we go. So the other equation is 1,000. It's negative 16t squared plus v naught times t. But, oh wait, sorry.
The v naught is
But I'm going to replace the v naught. I'm going to replace the v naught with, I'm substituting the other equation in, right?
32t. Yeah.
So it's 32t times that other t, right? 32t times another t. So it's 32t squared. So cool. So now I can solve this and I'll get t. Guess what? I don't really want t. But that's okay. After I get t, I can throw it right back there and I'll have what I want.
Yeah.
This is easy now. This is negative 16 and 32. That's a positive 16t squared. I would divide by 16. I would take the square root of both sides, and that's my t, I think. You could make that a decimal, or you could call it 5 halves square roots of 10. Jesus. Or you could make it a decimal. What is this, 62 point something? Somebody did this. 62.5. See, some of you had some numbers, but you know what? A lot of you call this t. This ain't t. The square root of this is t. I don't know. Anyway, what is that? You can go ahead and estimate it. You know, in word problems that we can go non-exact.
Right.
In word problems, it's cool to decimalize
Right. Makes sense.
because it's a word problem. You want to know. I don't care. All right, I'd like. So how many seconds is this? 7.91 seconds. So cool. I can take this and go right there. And so V naught is 7.91 times 32. 252.98. So that was on your quiz. Yes.
Do we have time for another question?
Yes.
Do you mind solving the Superman problem from
Yeah.
and
The Superman problem's good too. That was on your quiz. You know, I'll tell you what, let me show you your quiz. Let me give you this back. But before you run away,